In this video, we're going to talk about how 3D printing has facilitated my career. Now, I'm here in Vietnam at the sample room, and that's just a fancy word for the prototyping shop. And I'm going to be able to give you guys a tour of the sample room here, as well as the factory floor, and talk about how 3D printing got me here. So let's get into it. Now this all started 6 years ago when I was in graduate school and I needed the bag to get back and forth to classes. You know, the DIY spirit and all of that being a thing, I decided to sew my own bag. So instead of spending the $300 on a messenger bag, which I wanted, I just made a crappier version of it by myself. And after I'd sewn that, I realized that the biggest problem with the bag wasn't even the fact that it wasn't made in a professional factory. It was the fact that it lacked the ability for the straps to pivot where they're sewn into the bag. So a sewn connection is a rigid connection. It's fixed. It does not change the angle. So I decided to make another bag using some buckles which rotate. And I went looking for those buckles and I couldn't find them because they don't exist. Fortunately, at the time, I had access to a Stratasys FDM 3D printer. So keep in mind, this was 6 years ago. And that was a point in time where this home-based 3D printing really wasn't nearly as good as it is today. So without the Stratasys 3D printer, I would not have been able to proceed. But if I was to embark upon this project again today, I would really be able to do all this with just one of these, the cheaper 3D printers, under $1,000. Any one of these printers under $1,000 would work to do the early prototypes. This is the original buckle printed on a Stratasys FDM 3D printer. And you can see the crack in it because I've broken it. You can also see the layer lines. So this is really no different than our home-based, you know, $200, $1,000 FDM machines we get these days. And this is an ABS material that they printed this buckle with. And you can see you press in the center and the two halves come apart. You can also see all these holes, and I literally stitched by hand this buckle onto my bag. So the needle went through each and every one of those holes. It worked. It was a great proof of concept, and it made me really excited to continue on with the project. However, there were a couple of problems. Mostly, I realized just how weak this design was. I mean, look at how much I can bend this thing. It's clearly not ready for prime time. But the main problem was a design-based problem, and that is if you turn it 180 degrees, the buckle just comes apart. So that's no good. You don't want that. You want it to work the way it's supposed to work. So clearly, that needs to be a full and complete circle. And so a couple of iterations later, I was experimenting with 1-inch designs. So this would take 1-inch strapping here across the top. And you can see that I've fully completed the circle. I've also sort of angled the circular profile, whereas before on the original buckle, it was a stepped design. You can see just sort of that step there. So I ended up with a combination step and angle just because it gave me the most strength. But yeah, this buckle and all the subsequent buckles after it were printed at Shapeways, and this is SLS printing. That's selective laser sintering, and that is a nylon print. You can see this white in some areas on this print, and that's just where the black has worn off because these are dyed. They're literally just dropped in a bath of dye, and that turns the all white print. So every print that they print from Shapeways comes white, and then they just change the color by dropping it in a dye bath. Eventually I decided to dye my own, and so that's what you see here, this sort of greenish color left over that's real scratchable. So they actually have better dyes than what I can get my hands on. But you can see I went back to the 2-inch design, and I also moved this bar. That's the bar here that's going to hold the strapping. I moved that closer to the circle because the closer it is, the shorter the lever arm. So if you look at this 1-inch design, that lever arm just sits way far off, so it gives it something pretty easily. If I push here, I could easily break that. So this is going to be much stronger. Now, instead of stitching these to the bag, I used the rivets to connect between the top and the back plates. So this was an experiment on a backplate. You can see I thought my name was going to be Circle Click. I don't know, not creative. But it got better, just like everything else. So there was a decent design. Pretty strong, quite functional, and almost went with it. But then I decided to make it organic. So with this buckle, I learned a version of CAD called Subdivision surface modeling, and that just allows you to get really great organic shapes. So my particular flavor of sub-D surface modeling was called T-splines for Rhino. And you can see here I'm back to that, stepped design. So I do have some radius on the step, but this turned out to be a lot stronger. So was back to experimenting with strength and with the organic shapes. This is the final buckle shape, and you can see we're with the 1-inch strapping just because it is a lot stronger. You don't have those lever arms that are easily broken. You can see the organic design, subdivision surface modeling again, and this is actually injection molded out of Delrin plastic, so it's very strong. Got the little detail of the push command so that people know to push in the center for the two halves to come apart. And you can see that the backing plate here is made out of a piece of sheet metal, which has been laser cut. So that just provides for a nice, really low profile backing plate that has threads attached to it. So it's a great solution for manufacturing. So yeah, I paid $10,000, actually like more than that, closer to 12, to get the molds cut for this exact buckle here. So you could see why 3D printing is so advantageous when I got a heck of a bargain on that mold to get it cut for that low of a price. And if I wasn't 100% sure of my final geometry, I could have really screwed myself over there. I mean, just 3 molds and you're $30,000 into your project. So yeah, 3D printing for the win. This buckle will hold 300 pounds before breaking, so just tremendously strong. And the operation is a whole lot more smooth than the SLS 3D printed version. And this is the final thing. This is what's going on to the bag. But see, now I designed every facet, every little angle, every bit of this buckle, and you can't know everything that's required on a brand new design like this from the first design. And you can only envision in your head so much of it. Even with a computer, with CAD, you can only look at it so much. You need to have the physical object in your hand. You need to put it on a bag and test it. So absolutely requiring 3D printing. You just can't do it without that. I think in the old days what they used to do is only the factory that could make injection molds quickly was able to do these prototypes, because they could make an injection mold, test it, make a new injection mold, test it, but the injection molds are tremendously expensive. I mean, we're talking it takes a very skilled CAD operator maybe a week sometimes to cut the molds. So you can imagine how that expense would get out of hand really, really quickly. So just the ability to draw it quickly and then test the physical object, it's changing the world. So this, I really strongly suggest to all of you to learn how to draw in CAD. And if you have an idea, start making prototypes and versions of it through your 3D printing. So yeah, so this is the core of the project. But a buckle is not the most attractive thing to the consumer. Yeah, it adds a lot of functionality, which makes you able to sell a bag. However, nobody's going onto the internet to buy a buckle, right? They all want a bag. So that's where the production shop came into play for me. Now, if you guys are interested as well, later on I can show you how I sewed bags there in America. But here in Vietnam, you can see there's those 2 prototypes. Those are messenger bags. And those are versions of this messenger bag, which I brought with me. And there's also, right down there on the floor, the flagship product for Pack Bags. And Pack Bags is my primary company. That's my startup. So we have, 24 hours left to go on Kickstarter, and we have funded. So I've placed the order for bags here at the factory, which is just really exciting to be finally shipping product after years of development. But let's take a look at how the buckles actually give a great functionality to that bag. So this is the bag, you guys, and you probably saw it in a previous shot behind me hanging on the wall. Anyway, we're calling it the One, and it's a travel backpack slash duffel bag. If you want to learn all about the bag, I'm going to provide a link to the Kickstarter campaign in the description down below. But for the purposes of this video, I'm going to show you how the buckles really just make it tremendously functional. So up here, there's 2 buckles kind of tucked away inside of this sort of padded pocket. And those buckles allow the shoulder straps to rotate. So when you're moving your shoulders as you're hiking or whatever you're doing when you wear your backpack, that actually makes it quite a bit more comfortable. So that's nice. Also, because the buckles are detachable, you can take the two straps apart here, and I'm not going to show it just because it's going to take too much time. Like I said, go watch the Kickstarter video if you really want an idea. But there's these other two buckles here that allow the two straps to be joined together into one single kind of cross body strap. And that allows you to wear the bag as a duffel bag, which is awesome because there are other bags out there on the market that are both backpack and a duffel bag. Let me see what I'm doing here. But those bags can't use the same straps. They have these two sewn permanently into the bag, and then they tuck away into a pocket. And then you've got this other duffel strap, which you would lose easily. So this allows you to have a lot cleaner of a solution. So down here on the bottom, we have this pivoting waist strap. And that, of course, uses another one of our buckles. So if I undo the flap there, you can see another one of the buckles. And of course, if I press in the center there, you can remove the waist strap entirely, so you don't have to have this big bulky waist strap whenever you're using the backpack. So pretty awesome functionality that the buckles provide. And as you've seen in this whole video, I could not have developed those buckles without the use of 3D printing. But that's only a part of the story. Obviously, developing the plastic buckles is only a small portion of developing a whole backpack. And I did sew the original prototype for this bag all by myself. But I eventually went to Vietnam. And so let's take a look more in depth at the whole factory process and the sample room there in Vietnam. Okay, so here we come into the actual sample room, and this is where the magic happens. I'm gonna walk into this corner here just so we can get a nice shot of everything that's going on. This is a great little machine. Really fantastic that they have this here. Just shows you how professional they are. So this is a CNC Knife Cutter. And what they're doing is they're cutting this thick paperboard, and they can make stiff panels of the actual panels that will be sewn into the bags. And they can then use those panels over here on this table. Yeah. Hi. So they'll take these knives and they basically just trace out the stiff paperboard panel, and that allows them to cut them. So here they are sewing. Hello everyone. Here we go. So these two desks are where they make the actual patterns. So these guys are working in like CAD, basically AutoCAD. And then they come up with the patterns, cut them on the paper cutter, and after that, they get cut out and then sewn. So we have 6 lovely ladies here sewing. And a lot of specialized machines. For instance, this is a bar tack machine. The only thing it does is sew back and forth to get a real strong mounting point for the webbing onto the actual bag. So right now, these lovely ladies are making it looks like they're making a 30-liter version of the bag for me, which is going to be a camera bag. So like I said, we're working on a number of new models, which is why I'm here in Vietnam to get those figured out. So it looks like we're making some more of the panels together over here. And you can just see all of the different materials that they have at their disposal, all the different types of zippers and buckles and all of that. So, and this is the main factory floor, you guys, where my bags are going to go into production within the next 30 days. And I can't express how excited I am to see my designs going into full-on production. And to think that it all started with just a little bit of 3D printing 6 years ago. So this is a great hobby, you guys. Stick with it. It can take you great places. And this is the CNC Sewing Machine corner of the factory where they do the really precise computer-controlled bits of stitching. Your embroidery and some fancy buttonholes, that kind of thing. And here in the background, what you're seeing moving is the CNC Knife Cutter, which they use to get very precision cuts on the panels for the bags. On larger production runs, they can custom tool some knives, in other words, just like a shape that's the exact shape of the panel, and then they use those green machines that you see in the background over there to press cut many panels. So the tools that they have at their disposal are second to none. Okay, I arrived back in the United States 2 nights ago, and you would think that because I'm back stateside, we could get to business as usual around here on design, prototype, test, and that would mean finishing the Delta printer, the Creality, and the Troncy on all those modifications that are in the works. Unfortunately, I have to go to Oregon for another business trip, so big apologies, you guys. I know I've been promising you that I'm going to get to those modifications, and they're still in the works. It's just that I have other priorities. I have to pay the bills. So that's going to be it for this video. So leave a comment, click all the good buttons, and thank you for watching. If you haven't seen all of my videos, I'm going to include a couple of playlists here, and that'll be about that. See you next time.